Hello, Mr. Aaron, Mr. Ryan, how are you today? Okay, yeah. Today we're going to talk about a math problem, okay? Probably no coding, okay? Just mathematics problem. It's from your book, yeah? Or from your book, math project. So 6 identical squares with side length of 3 centimeters. So 6 squares, okay? Each one 6 squares, each one with size 3. We want to put it to form a large rectangle. We want to put it into a large rectangle. What's the maximum perimeter? What's the perimeter? You know the perimeter. If it's the 3, what's the perimeter of this square? Perimeter. The possible rectangles from here. What's the perimeter?
The outside.
It's the outside. So what's the perimeter of this square? It's
12.
12, yeah. Because 4 sides.
Because we're gonna take
And there are 6 of it. So how can we rearrange the rectangles into using the 6 rectangles into a rectangle? Yeah, 6 squares using a rectangle. One way of doing it is you can put it.
10.
Right? Look, you can put this. Yeah, 6 squares rectangle.
10.
Or
Like Ryan said.
you can put it side by side. So that's another way of doing it. Okay. Any more? Look, this one is two rows, 3 columns. Yeah, 2 rows, 3 columns. How about three columns, 2 rows? How about 3 columns, 2 rows?
Still the same as the 2 times.
Yeah. These two are the same actually. You just rotate. It doesn't change the parameters. Yeah? We are looking for the maximum parameter. Maximum parameter. My parameter. Okay, maximum. So what's the parameter of this one? What's the parameter of this one?
10, like Ryan said.
10? How do you?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that means 30.
Yeah. Oh, okay.
Because it's 3.
Okay. 1, 2, 3, 4. Is 1, 2, 3. 6 times 3 times 2. 6 plus 4. 10. So 10. 10 times 3.
Yeah,
30.
we said that.
30. Okay. The parameter is 30.
Yeah, I said.
And this is obvious 30. And how about the second one? What's the parameters of this?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. 42.
42. Yeah, look, 1, 2, 3, 4, 5, 6. 6 times 2, 12. 12 plus 2 on each side is 14 times 3 is, 14 times 3. Okay, so which one is the bigger?
That one.
Yeah, that one. Okay, so this is quite simple. And how about I tell you if there are 8 rectangles, and what's the maximum we can get?
That line. 1, 2,
Yeah.
3, 4, 5.
So what's the strategy of this?
The line. 11,
Yeah. How do we put it? Why is it? If they are n, how do we put it? We just put it one by one, right?
Yeah.
Why is that? Why this is optimum?
Because when you do like a square like
Yeah.
this. That's 7. When you do like a square like
Yeah.
this.
Yeah.
You have more in the middle, and you gotta have the double
Yeah,
in the
exactly. Let's compare the 6th one. Look. So if the unit is each unit is 3.
Whoa.
How many if there are 6 rectangles 6 squares, how many? 1, 2, 3, no, that's more than that. Okay.
The 8.
Okay,
Now
that's
that's
6. Yeah. If 6 rectangles, each one is side of 3. And how many sides of that? 4, right? This is total number, the parameter you can get. You can put it disconnected, okay? Alright, Ryan?
Yeah.
So that's how many? That's 72, right?
Yeah.
72. If you
That's a lot.
No, if you put it this one by one, okay? What I'm saying is that if you put them disconnected, what's the total parameter? Alright, what's the total parameter? So each one
72.
is 3 times 4
3, 6,
6,
9, 12,
yeah?
15, 19, 21.
Okay, so what happened if I do this to here? Look, what's happening? What's happening? Alright,
Yeah.
what's happening from here to here? What's happening?
Because you start.
Yeah, the middle. Yeah. So how many joint edges are there?
2, 4, 6, 8, 10.
12. 2, 4, 6, 8, 10, right?
Yeah, I said 10.
10. Okay, so look, so that's parameter of this one is what? 72 minus 10 times 3 equals what? Equals what?
Equals 42.
Yeah, that's how we got. And how about this one? 72 minus, how many edges are there?
2, 4, 6, 16.
For, yeah, 16, yeah?
Yeah.
16 times 3, 48. Is it 16? 2, 4,
Oh no, 14.
14, yeah? 14. 2, 4, 6, 8, 10, 12, 14. So that's what? 30, yeah? That's how we got 30. So look, this number we can calculate is always fixed. Yeah? This number is fixed. This number, let's say, is t minus these joint edges, the internal edges, like a. This is the number we want to maximize. We want to maximize this number. We want to maximize this number.
Ow.
We want to maximize this one. This number is fixed, so we have to.
Fixed.
So this number has to be bigger or smaller. If we want this whole thing to be bigger, so we want this number to be smaller. How do we put it smaller? What's the ultimate solution?
Put in the line.
Put it in the line, right? So it doesn't have cause more internal edges, right? If I tell you there are a million rectangles, squares, and how do we arrange it to? You don't need to give me the answer. A line. You just put it one by one, yeah.
You do.
Okay. This is rectangle, yeah. This is
The
rectangle.
answer was, if the answer is gonna be
And what's the parameter? Okay, if there are
2
n.
million, then
No. If there are n rectangle, okay, you just tell me the n rectangle. Each side is m. Okay, each side is m. And what's the maximum parameter you can get? What's the formula? If there are n rectangle, how many edges? Joint edges. 1, 2, 3, 4, 5. There are 6, yeah. So it'll be 6. It'll be n minus 1, right? N minus 1 times 2, right? And then times m, right? This is number of internal edges you can get. So the answer will be what? The answer will be what? Can we do this? M, this is the unit, times what? N minus 2 times n minus 1, right? Let's say if there are 4, what's the answer? 4. 1, 2, 3. 3 times 2, 6, yeah? 4, yeah? Okay? So the answer is what? Answer is this one. Is it right? No.
no.
Is it right? Look, there's something.
Ow.
Can I have your attention, please?
Yeah, we're listening.
If there are n, these to be n
no.
squared, right? So each one, the total one will be times 4. Okay, we forgot the times 4, so they will be 4n. Yeah. So that answer will be n times 4n minus 2n, and then plus 2, right? So this is 2n plus 2. So the answer will be 2n plus 2 times n. Okay, let's use this 6. If n is 6, 2 times 6, 12 plus 2, 14 times 3. Okay? So the answer is this one. Got it?
Yeah.
Make sense?
Yeah.
This is greedy, okay? We call it greedy because we know we know the optimal solution. Okay, I'm going to do that one more time. Can you listen to me?
Yeah, we are.
So there are n. This is the ultimate. We just proved that it's the ultimate.
Because
And there are n. So what's the total number of parameter for the n squares?
Okay, so it's n
Times-
times 2.
No.
N times 3.
M, and the side is m, right? This side is m. N times m, but each one is, there are 4. 4, right? This is the total. And then how many edges in the middle?
36.
N minus 1 times 2, right? So this is the answer. So look, 4n and times m, right? So we get this n common terms, yeah? So m times, the answer is 4n minus 2n plus 2. And that will be m times 2m plus 2. Right? Look,
Yeah?
if it is 8, let's do this 2. 4, okay? 4. Do this or this. This is bigger, yeah? Obviously, this is bigger. So look, this is what? How many edges? If m is 1. So 2 times 4. 2 times 4 plus 2 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it?
Yes.
So if we write this, define. So we can, if we want, we can just write this. Define, yeah, maximum parameters. And then we can say n squares, each side is m. And we just return what? Return n times 2n plus 2. Okay, what's the time complexity for this one?
O, N.
Come on, don't just guess. What's the time complexity?
N.
Come on.
1.
01, come on, 01.
Yay!
Because there's no, we just calculate this, right? There's no,
Thanks for the parcel.
n is the median. If n is the median, it's still constant.
N is a
Okay.
minion.
Okay, let's say you want to do some goodbye things. Okay, that's it.
I'm gonna take one.
Okay, that's it for today. Goodbye.
Right.